Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the Blind Leetcode 75 problems list. In this video I will be solving problem 125, which is called valid palindrome, which is one of the most basic string problems that you can do in Leetcode. So definitely a good starter if you want to start preparing for string questions. So let's get to read the problem statement and then solve the problem. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. So let's look at the examples. So here we have an input, that's this, and the output is true, because once we remove the spaces, the commas, and any single non-alphanumeric character, we have this string right here. And after we turn the uppercases into lower cases, and then if we compare letter by letter, so the first one with the last one, second with the penultimate, and so on, then they end up being the same. This is not a palindrome because so the first three and the last three are the same. And once we get to the E and the A, these are not the same. So it's not a palindrome. So it's pretty straightforward. And the empty string is also not a palindrome. Great. So okay, if you want to attempt to do this problem by yourself, now will be the time to stop the video, because I'm going to discuss now how to solve it and what my approach will be. Okay, so let's get to it. So the main idea here, I guess, what you might think at first is, okay, well, what if I just remove all non-alphanumeric characters, right? And transform any lowercase into uppercase. And yes, that is an approach that could work. However, it'll take you more time than it should, and you're going to have to use a new string, since strings are immutable, so you can't modify the original one. So you're going to have to use O of n space in the worst case scenario, and you're going to have to go over the string twice. Once to remove all the characters, all the non-alphanumeric characters, and another one to check if it's a palindrome. I will show you that you can actually solve this problem just for one pass, meaning that you have to cover each character in the string just once. You don't have to cover it more than once. And how will we do that? Well, the main idea here is pretty simple, is we start with 2 pointers, one in the beginning of the string and one at the end of the string that's given to us. And what we have to do is very simple, is if both the left and the right string point towards an alphanumeric character, then we compare them. Obviously we have to set both into lowercase because we make no distinction between lowercase and uppercase, as stated in here in the problem. So both of them are alphanumeric. If we turn them into lowercase and they're the same, all that we have to do is advance the left pointer by 1 space and decrease the right pointer by 1 space. Now, what happens whenever one of the pointers points towards a non-alphanumeric characters, for example, a space? When that happens, for the left pointer, we simply have to increase it until we encounter an alphanumeric character. And for the right pointer, we have to decrease it by 1 until we encounter a alphanumeric character. And that will be the main idea behind the algorithm. And when do we know whether we found a palindrome or not? Well, we will definitely know that our string is not a palindrome if we are pointing towards 2 alphanumeric characters with our pointers and they're not equal. Their lowercase versions are not equal. And it will be a palindrome whenever the left pointer overcomes the right pointer. That's simple. So whenever the left pointer is either greater or equal to the right pointer, at that point we have already covered every single letter in the beginning and the end. In the case that they're equal, right, both of them will point towards the same letter. So obviously comparing a letter to itself is redundant. You don't need to do that. So yeah, that'll be it. So let's code the algorithm now. So let's start with the pointers. So the left pointer starts at 0, and the right pointer starts at the end of the string. Remember, length of string minus 1. Now we will simply do the while loop that will determine whether that we will use to traverse through the entire string, and whenever we exit it, if we exit it, then we know it's going to be a palindrome. So while the left pointer is less than the right pointer, so whenever we exit this, we will simply return true. So we can just leave that there for later. And the first thing that we have to check is whether the left pointer or the right pointer, it doesn't matter which one we check first, but let's do the left pointer first. So if the left pointer is in a non-alphanumeric character, right, then we have to increase it by 1. But keep in mind that there could be multiple non-alphanumeric characters together, like for example here on the right pointer. So we should do this repeatedly until we encounter an alphanumeric character. So in order to do that, we will write a while loop. So while s left pointer that is alphanumeric, I think this is the method in Python, hopefully it is and I remember it properly, is equal to false, then we increase the left pointer by 1, and while s right pointer that is alphanumeric is equal to false, right pointer minus equals 1. Now, another thing that we should also keep in mind is that we never want the left pointer to be greater than the right pointer, right? So we can also add this comparison right here to the while loops here. So and left pointer less than right pointer. And after that, all that we need to do is compare the left pointer and the right pointer. So if s left pointer does not equal s right pointer, then we return false. Else, we just increase right pointer. I don't want to leave these spaces here. We increase left pointer by 1, and we decrease right pointer by 1. So increase left by 1, decrease right by 1 repeatedly until we can exit the loop or we encounter two characters that are not the same. And I forgot to use the is lower method, the lower method. So sorry for that. There you go. Dot lower. And this should turn them into lowercase. I hope these methods are the right ones. So let's see if we run this. Okay. And it works. Obviously, as usual, you know, runtimes are a bit inconsistent, but nonetheless, they work. So, what is the runtime and the spacetime complexity of this problem? So, the runtime complexity of this problem is big O of n, because we are going to cover, in the worst case scenario, every single character in the string. Where n is the length of the string, therefore the runtime of the algorithm is big O of n. And what is the spacetime complexity? Well, we are only storing 2 pointers that are represented by an int, so each of them takes O of 1 space. And we're not storing anything else, since we're just simply comparing elements that are already given to us in the string input. Therefore, the spacetime complexity will be big O of 1. And that will be the end of this problem. So thank you very much for watching the video once again. I hope you enjoyed it, and I hope you found it very helpful. See you in the next one. Bye-bye.